This is another area of a composite figure. You can see from our work before. But we're going to focus on this circle question. This one's a little trickier. So we're looking for the area of this. And essentially, we have two shapes. They're both circles. I will do my best to quickly freehand one. Oh, when I draw it faster, it works out much better. Oh, I should do that from now on. So I'm going to redraw the two of them. One of them has a radius. So this is a radius, which is from the center to the outside. All the way across to the middle is diameter, but this is radius. Radius is equal to 7.5 inches, it says. It also says the radius of this one is 2 3/4 inches. Okay. And it turns out there's a hole in the middle. I'll even kind of color it in black. This is a hole in the shape. So in other words, we are going to get the area of this shape, and then we're going to subtract the area of this shape to find out what the area of what's left. Okay. Our area of a circle is equal to pi, which is a value, multiplied by r squared. Okay, great. We know radius, they've given it to us. But the problem is I have to square it, which means I have to multiply it by itself. Multiplication of fraction works way better when they're improper fractions. These are currently mixed fractions. So we got to do a little work. We have, and I'll move it to the side or up a little here. We have 7 1/4. I need this to be an improper fraction. So the denominator will stay the same, but the process to make it improper is we take the denominator, we multiply by this whole number, and then whatever that is, we're going to add it to the numerator, okay? So on the side, what that looks like is 7 times 2, which will give us 14. And then the numerator was 1, so we add that, 15. So we're going to say the radius of this is 15/2 inches, okay? We're going to do the same thing with the other number, and then we'll be able to work through this math. So same idea. We have a whole number 2 3/4. We already know that the the denominator will be the same, the number on the bottom. And our process here is we multiply the denominator by the whole number, and then we add it to the numerator. So 4 times 2 will give us 8. And the numerator was 3, so we add it, gives us 11. So this becomes 11/3. Oops, I lied. Not over 3. 11/4 inches. Okay? So that brings us back down here. Let's go to this piece. Oops. We're going to replace our r with our new improper fraction, because pi is a value. Pi times 15/2, we're going to start with the bigger circle, squared. So we can work that out. 15/2 squared is technically pi, and what you're going to do is 15 times 2 times 15 times 2. And with your calculator, you'll definitely use a calculator because you have that real number of pi. This will be pi times 4, 15, 125? I think it's 125. Hey Google, what's 15 times 15? Or is it 225? No, it's 225.
The answer is 225.
There we go, okay. This last piece I can't do in my head, so we need a little calculator for that, okay? Then we repeat the exact same process. The area of the other circle is pi times their radius. Well, their radius was 11/4, and we have to square it. Same steps, pi times 11/4 times 11/4. That's all that squaring means. 11/4, when we multiply it by itself, gives us 121/16. And that, again, is some number I don't know off the top of my head. What we can do is, this might seem a little different to you, 225/4 pi. I'm just going to write it beside each other. And this is 121/16 pi. To get the area, we just have to subtract these two values. So I can technically say 125/4 pi, subtract 121/16 pi. Okay? Now, that might seem different. You can make numbers that are a lot easier for you to understand. But technically, I can do this. Think of this literally as pies. It's like you saying you have this many pies subtracted by this many pies. Our answer will have some number of pies in the end, But we'll have to subtract those fractions. I'll probably suggest you use a calculator for this piece. I'll quickly do the fractional subtraction so that you can see it. We have to get a common denominator, so if I fire it over here, we're going to have to be over 16, both of them. This one will stay the same because it's already over 16. This one had to be multiplied by 4. So this part's not too important. This is where a calculator can come in handy. If I multiply that by 4, I get 2, carry 8, 0, carry 1, 900. So 900 over 6 is going to go 800, 779, I'm pretty sure. So whatever this is when we multiply it, let's see if Google will give it to us. Hey Google, what is 779 divided by 16 times pi?
The answer is approximately 152.956292.
95-ish. So we'll say approximately this. And again, same idea, but this one is in inches, and because it's area, it's squared. So similar idea, other than I did a little bit of fractional division there. Composite figure is the same concept. There's two different shapes, and we're either adding and subtracting their areas to figure out what the area of the composite figure